Example number 3. Flying into the wind, an aircraft, not and, as the book says, made a 360-kilometer trip in 2 hours. The return trip with the tailwind took 1.5 hours. Find the speed of the wind. Now, to visualize this problem, you need to do two things. First, you need to know that x represents the speed of the airplane. So when you're going into the wind, you'll have y, which represents the speed of the wind, and so you have the component flying into the wind and flying with the wind. So the speed flying into the wind is x minus y. The airplane will be slowed down by going against the wind. With this, you have to know you're going 2 hours, so 2 times x minus y is equal to 360. That will be the first equation. When you're flying with the wind is pushing you forward, you gain speed, so you'll have x plus y. To go with the wind means you go faster. To go into the wind means you go slower. So when you fly with the wind, it takes you a shorter time. It takes you 1.5 hours. So the other equation is 1.5 times x plus y is 360. So you have two components of the trip. Flying into the wind, I've rearranged the equation slightly, so I have the coefficient first and then the variable component next. So 2 times bracket x minus y is equal to 360. And the second part of the trip, flying with the wind, is 1.5 times bracket x plus y bracket equals 360. Now notice that I cleverly divided for line 1 all components by 2. This will be useful because I can now isolate having variables x minus y equals 180, so that I have a 1 in front of these variables. So if I want to substitute or eliminate, it's easier to do so. And similarly for equation 2, I divide both sides by 1.5 to get x plus y equals 240. I cleverly did this so that, again, if I want to substitute or eliminate, it makes it easier to do so, rather than working with numbers and fractions and decimals. So notice that equation 1 and equation 2 are recorded as x minus y is 180, and equation 2 is x plus y equals 240. Now, since we want to know the speed of the wind, I want to solve for the variable y. That means I want to subtract both lines to cancel the x, so that I am left with a quantity for y. So line 1 subtract line 2 yields negative 2y is equal to negative 60. I divide both sides by negative 2 and I get y equals to 30. So therefore the speed of the wind is 30 kilometers an hour. And that's how you do this type of